Okay, so this is kind of a couple of special cases that, rather than being more difficult, actually make it easier because there's a very clear rule for what you do in order to find the product of the binomials when you have, uh, first of all, when you have a square of a binomial. So that's what we'll talk about first. So here's the idea. Um, it could either be plus or minus here. It's going to slightly affect the answer, but generally it looks like this, okay? If you have a plus b squared or a minus b squared, then that's really looks like this, right? A plus b times a plus b, okay? And if you were to do the FOIL method, you would say first times first, you're going to get that a squared, okay? Um, last times last, you're going to get this term, okay? So you got first, you got last, you need outer and inner. Watch what outer and inner does. If you did outer, you'd get a times b, or ab, and then inner, b times a, or the same as a times b, ab again, or ba, right? Those are the equivalent things. So how many times do you have ab? You have it twice. So now down here, you've got that 2ab, okay? Essentially, you've got, when you're taking something like a plus b all squared, like what you've got here, what you get is this squared on the front, this squared on the back, and in the middle, you get 2 times the first term times the last term. So this times this, AB, you get that twice, and that's right there. Okay. Here's on the right-hand side. Here's the area tiles for it. If you did a plus b times a plus b, this is a and b. That's a plus b for that length. And this is a plus b for that length. You get the a times the a squared right there. Okay. You get the b part times the b part, b squared right there at the end. And then for this side, you get a times b, ab right there, and a times b right there. Okay, so you get a squared plus 2ab, because you get it twice, plus b squared. Okay, and so the rule we can say is the square of a binomial is the square of the first term plus twice the product of the two terms plus the square of the last term. Now notice this, if it was a negative in there, you'd get a times negative b, you get negative ab, right? And since you get that twice, you get negative 2ab. So everything else is the same. Even this is still positive because watch, what's negative b times negative b? Well, negative times negative is positive. Whenever you square something, you get a positive. So you're still going to get that positive b squared there, okay? Now remember, it's not going to be a plus b. It might be like 3x plus 2 or 4x minus 5. But it's still going to be whatever that first term is, squared, times, I'm sorry, plus or minus, depending on what's here, 2 times ab plus b squared. Okay, so here is an example. They have x plus 4 squared. That's x times x squared. 4 times 4, 16 for there. And the middle term is x times 4, or 4x doubled because of the 2ab, right? 8x. Same thing here. You get x squared for there. The middle term is x times negative 3, negative 3x doubled to negative 6x. And then at the end, you get negative 3 times negative 3, or positive 9. Okay? So that's the big ideas with that. Let's do some problems. Okay, so let's do one of these. Um, what is a simpler form of each product? Basically, they're saying write it in kind of, you know, write it in this form, expanded and multiplied together. Okay, so how do we do this? It says square the binomial. So we say, okay, this first term here, squared, x times x, x squared. Okay. The middle term is twice the amount of this times this. X times 8 is 8x, and when you double that, you get 16x. Okay, and then finally this squared. 8 times 8 is 64 right there. So you get x squared times 16x plus 64. Okay, now b is, notice what they say here about b. What rule can you use to simplify this product? Well, you know, it sometimes looks a little bit funny because it's not described in terms of a and b, but 2m minus 3 is just a is 2m and b is 3, and you're doing a minus b squared. So you just still do the same rules, which is you square this, 2m times 2m, 4m squared. For the middle term, you multiply these two together and then double it. So 2m times negative 3 is negative 6m. Doubling gives you negative 12m. And then squaring this, negative 3 times negative 3, positive 9. So it all works out the same way, okay? Here is your got it problems, and you should do these. These are important to know, especially for upcoming courses, particularly Algebra 2, but you are going to need this regardless anyway. So pause the video now and multiply these using the rules that we just did, and unpause it when you've got your answers to compare. Okay, pause it now. Okay, so how are we going to do this? Well, what we're going to do is we're going to square this first term, n times n squared. And then we're going to take the two terms in here, n and negative 7, multiply them together, and double them. What is n times negative 7? It's negative 7n. Doubling negative 7n, you get negative 14n. Okay? And finally, we have to square this last term. What is negative 7 times negative 7? It is positive 49. And if this is negative in here, the only term when you square it that's going to be negative is this middle term, okay? Because this is, anytime you square this, you're going to get a positive because you're squaring. Anytime you square this, you're going to get a positive because you're squaring, okay? That's squared and that's squared, but this is not from either of those terms squared. It's from one term times the other term and then doubled, okay? So if it's negative, it'll still be negative here in the middle. B is not negative. Let's do it. We say, what is this squared? What's 2x times 2x? It is 4x squared. What is 2x times 9? It's 18x, and we need to double it. So 18x and 18x is 36x. And then finally, what is 9 squared? It is 81. And you got to put plus because it's positive, okay? Since these terms are separated by plus or minus, anything that's positive has to have a plus in front of it. And that is how you do that. Hope that made sense and was pretty straightforward. Let's keep going. Okay, so what we're doing here now is just applying this to a real world problem. Okay, and let's read the problem. Exterior design. A square outdoor patio is surrounded by a brick walkway. Here's the brick walkway in maroon. What is the area of the walkway? So if you find the total area of the patio and the walkway, all of this, and then you subtract away the area of the patio, so you find the total area of the patio and walkway, find the area of the patio, and then the walkway will be whatever's left when you take that total area and you subtract away the area of the patio. So what do we call the entire thing? Well, we've got, just notice how did they get this measurement right here, okay? They say this is some X number of feet long. We don't know, so we call it X. But since the walkway is 3 feet on each side, then you say, here's 3 feet of walkway, then this interior starts, and then another 3 feet of walkway. So since this is some X number of feet we don't know, we say that X number of feet here plus 3 feet on each side is X plus 6 for that whole length. And it's a square, so it's the same way. There's 3 feet of walkway, X feet, and then another 3 feet of walkway for a total of 6 feet of walkway in addition to that X number of feet. So we're going to have to square this. We're going to say square this, X plus 6 squared. So x times x, x squared. X times 6, 6x, times 2, 12x. Square this, 36. So that is the area of the entire space algebraically, right, in an algebraic expression. Now let's find the area of the patio. Well, we know that the patio is x feet by x feet, and that's easy. X times x, x squared, okay? So what we do is we take the area of the total area, and you subtract away the patio, or the total area which we found up here, which is this, and you subtract away the area of the patio, which is this. That takes away this x squared. Okay, those two cancel each other out, and what you're left with is 12x plus 36. That's the area of the walkway, 12x plus 36, and that's of course feet squared. This is not squared. It's just whatever x is, then the area of the walkway is going to be 12x plus 36, plugging that number in for x if you knew it, and to get an actual number of square feet. But we don't know it, so we just say it's 12x plus 36 square feet. Now, in problem number two, suppose the brick walkway was 4 feet wide. How would that change things? What's the total area? This is your got it problem, so you're going to pause it right now, and you're going to try and figure it out, but you're basing it on what we just did. So you can look back at this problem and see what we did there, and you're going to adapt your numbers to this new bit where the walkway is 4 feet, okay? Pause the video now, and unpause it when you have an answer that you want to compare to mine. Okay, so if the walkway is 4 feet wide, then we have here 4 feet plus x number of feet plus 4 feet. 4 plus x plus 4 is x plus 8, right? So instead of up here where they had x plus 6, we're going to use x plus 8, and we're going to square that. X plus 8 squared. Okay? And of course, we're going to subtract away from that minus this amount here, x times x, or x squared. So we'll do that minus x squared. Okay? Now let's expand this right here. And how do we expand that? Well, we say we square the first term, x squared. And for the middle term, we do this term times this term, x times 8, 8x, and double it to 16x plus 16x. Okay, and for the third term, we square this. 8 squared is 64 plus 64. And remember, then, we're now subtracting away the x squared, the area of the actual courtyard. So minus x squared. And you should be able to see then that this x squared minus this x squared cancels out. And what you get as an answer is you get 16x plus 64, all of that, feet squared. Okay? The reason that we put it in parentheses is to show that the feet squared applies to the 16x as well. Okay? And it's not just 16x plus 64 feet squared. Right? It's this whole amount, whatever number you would get if you knew the width of the courtyard and plugged it in there, you'd get some number, and it would be that many feet squared. Okay? So that's your answer. Okay, this next bit, actually I learned this a long time ago, and I just use this in my life sometimes whenever I can. It's a pretty cool trick. If you want to find the square of a number, you can use, and it's not a nice neat number, you can use the square of some nice neat number as the basis of this, and use basically our binomial rule. So check it out. Look at how you do this. Okay, what is 39 squared? Okay, well, I don't know, but 39 is really close to 40. Now, it's just a fact that you can do 40 squared in your head. Hopefully you drop the 0. 4 times 4 is 16, and then add 2 zeros on. Okay, so what you're doing here is you're saying, if I wanted to do this mentally, I would say my rule is this squared, this squared, right, 1600, minus 2 times this, negative 1 times 40 is negative 40, doubled is negative 80, and then this squared is positive 1. So you say 1600 minus 80 is 1520, plus 1 is 1521. Now, you might not choose to use this trick when you're trying to calculate this, but you should understand that it works, how it works, and how the rule that we learned applies to it. I kind of really like this. And if you were doing 41 squared, it would be just, instead of negative 80 here, it'd be positive 80, and you'd get 41 squared would be 1,681, and you can check that to see that that's true. okay? You've got then a got it problem. What's 85 squared? Use mental math. Is there more than one way to find 85 squared using mental math? Explain your reasoning. So I'm going to let you pause it, and you're going to give this a try and see what you come up with. And then you're going to compare it to mine. I'm going to do it mentally for you and see if me doing it mentally helps you, or else I'll do it sort of mentally. I want to write something that you can look at. But pause the video now, try and do this based on what you just learned and see if you can do it more than one way, and I'll show you what they're getting at in a second, okay? So pause the video now. Okay, so essentially if you're doing 85 squared, you can think of 85 as 80 plus 5 squared, right? And if you squared 80, 8 times 8 is 64, add those two zeros, 6,400, okay? For the middle, you've got to multiply this times this times this is 400, and when you double that, you get 800. And then, of course, you square this, and that's 25, okay? So adding these together, 64 plus 8 is 72, so 7,200, and plus 25 is 7,225. We did that sort of mentally. I wrote stuff down so that you could see it, but basically mentally. Now, is there another way you could have done that? Yeah, actually, watch. You could have, instead of seeing 85 as 80 plus 5, you could have seen it as 90 minus 5 squared. That's still equal to 85, 90 minus 5. So let's then do it that way. Well, 90 squared, 9 times 9 is 81. Add the two zeros, okay? Now right here, you get 90 times negative 5. Well, I know it's going to be a negative number. 9 times 5 is 45. With a 0 is 450, negative 450. I have to double it, and negative 450 doubled is negative 900. And then, of course, this squared, negative 5 times negative 5, is positive 25. Okay? Now, what do I get when I do 8100 minus 900? Well, 81 minus 9 is 72, so 7200. I've got to add this 25 on, and we get 7225, whichever way we did it. Isn't that pretty slick? Yep, that's mental math, how you do that. You'll be actually asked on a test and a quiz to do this and to show what you did. So plan on understanding that doing this is simply this squared or this squared, and then you're applying the same rules that we're using for the binomials when we square them. All right, now, what we just learned was if you took one binomial and you squared it, you multiply it by the exact same binomial. Now we're going to learn the special case of taking two binomials where one of them is a plus b and the other one is a minus b. And this comes up a lot in Algebra 2. And if you can get your mind around it now and let it sit and percolate in there for a year, then you're really going to have a way easier time in Algebra 2. So invest in your future a little bit by really studying this well. Okay? Now, how does this work? Let's do our first, outer, inner, last for this. Okay? If we do first, a times a is a squared. And we do last. Last is this times this, okay? It is b times negative b. So positive times negative is negative, and b times b is b squared. So for a times a, we got a squared here. For b times negative b, we've got negative b squared here. Now watch what happens with the outer and inner. For outer, we get negative ab, a times negative b, negative ab. And for inner, we get positive ab. And what do negative AB and positive AB do? They are exact opposites and they cancel out and go away. So what are you left with? You are left with this term squared minus this term squared. It says here, notice that the sum of negative AB and BA, or AB, that's another way of writing it, AB, is 0. So it drops this out, okay? And this is a very, very classic thing that once you see it, oh yeah, we have the exact same binomials except one of them is positive in the middle and one of them is negative in the middle. You're going to get what's called the difference of squares, meaning difference, it's a subtraction problem, and this is a perfect square and so is this. So you get the difference of two perfect squares, a squared minus b squared, okay? Let's see what the rule is here then. Product of the sum and the difference, meaning the sum part means we had plus there, or let's do it down here, we have a plus there, and a difference, meaning we have subtraction there. One is positive, one's negative in the middle, okay? The product of the sum and the difference of the same two terms, a and a, b and b, just one's being added, so it's a sum, and one's being subtracted, so it's a difference, is the difference of their squares. You square this term, 8x squared. You square this term, 4. And it's subtraction in between them because you have one sign of each. Okay, that's the rule. So let's now apply that to some problems. Okay, so finding the product of a sum and a difference. It's a sum because there's adding, and a difference is subtracting the same two terms, x cubed and 8. One of them is being added, one of them is being subtracted. These are not the same binomial twice. So you're not squaring it. We're not using the rules for squaring. And in fact, here it says, how do you choose which rule to use? The first factor in the product is the sum of x cubed and 8, and the second factor is the difference of x cubed and 8. Since there's one is a sum and one's a difference, you use the rule for the product of the sum and the difference. Okay? And what do? Okay, we write the original product, and then we say, okay, what are the terms? We've got x cubed is the a term, and 8 is the b term, right? It's that first term and that second term. Okay? Identify which terms correspond to a and b in the rule, and then you substitute for a and b in the rule, which is a squared minus b squared. So you take this and you square it. What's x cubed times x cubed? X to the 6th. What's 8 times 8? 64. And remember, it's got to be subtraction in between here. That's what it's got to be, because you have one of each, which turns this to subtraction, and one of each also makes the middle terms drop out. If these were the same sign, you wouldn't get those middle terms dropping out. So they have to be different signs, which means this has to be negative in between. Okay, that's it. So here are 3 things that you need to multiply together. It's applying this rule. So you're going to pause the video right now, and you're going to write your answers down and compare them to my answers. Please do pause the video and have answers for all 3 of these before you unpause. It's the way you got to do it. Okay, so do that right now. Pause your video. Okay, so how do we do it? Well, really simply, and this is, as far as I'm concerned, this is really simple and straightforward if you understand that you're dealing with this type of problem. You say, oh, we've got x and 9. One time they're being added, one time they're being subtracted. So what do? We have the difference of the 2 squares. We square x squared, minus, and we square 9 squared. Blammo, done. That's it. Do it again. We have these 2 terms, 6 and m squared. One of them is being added, one of them is being subtracted. So we do the difference of 2 squares. We say, what's 6 times 6? 36. Minus, because it's always going to be minus in this case, what is m squared times m squared? Remember, you add the exponents when you're multiplying. M squared times m squared is m to the 4th. Done. Blammo. And finally for c, we have the 2 terms of 3c and 4. Here they're being subtracted, here they're being added. It doesn't matter that the subtraction is first, it's just that one of the binomials has subtraction, one of them has addition, and otherwise those terms are the same. Okay, so we say, what is 3c times 3c? It is 9 c squared minus, because it's always subtraction between it. And what is 4 times 4? 16. Difference of two squares. That's how you do it. I actually really like these because they're so straightforward. And yeah, I like them. So let's keep going, finish this out. Okay, last problem. And here it says you can use the rule for product of a sum and a difference to calculate products using mental math. What is 64 times 56? Well, we need to have basically the same number in the front and in the back of our binomials, right? One being added, one being subtracted. So how can you write that as the product of a sum and a difference? Well, let's find out what's halfway between 64 and 56. Exactly between 64 and 56 is 60, right? They're each 4 units away from it. So essentially you can write this. You can say 64 is just 60 plus 4, and 56 is just 60 minus 4. Because you found out what the middle number was, right? And you can actually just subtract them to find out how far apart they are, and then take half of that amount. And you say, okay, then I must have to go 4 down from this, or sorry, 4 down from this and 4 up from this. So you get your 60 and you get your 4. Okay? Now let's do what they tell us to do. Remember, if it is the same two numbers with an add here and a subtract here, then we just square that. 60 times 60, 3,600. 4 times 4, 16. So we do 3,600 minus 16. And that's what you get. Okay? You're going to do that now with your got it problem. Pause the video right now. See if you can apply what we just did. Essentially, you need to find out what number is right between 52 and 48, and then write it in these terms and calculate it like that. Okay, pause the video now while you do this. Okay, so one way you could do it is you can just say, let's subtract them to find out how far apart they are. They're 4 apart, and that means that we've got to do that 4 divided by 2 is 2. We need to go 2 up from the middle number, or sorry, 2 down from this, and 2 up from this should find you the middle. So what's 2 down from 52? It's 50. So you can write that as 50 plus 2 more gives you the 52. Okay? And then for the second number, you can write that 50 right in the middle of them, minus 2 is your 48. 52 times 48. Okay? And remember, when you have one of each of these signs, the same two terms with the different sign between them, you square the first number, 50 times 50, 2,500. 2 times 2 is 4, and we always subtract in between. What's 4 less than 2,500? It's 2496. Done. That's it. That's how you do it. That's your whole lesson. You're going to want to practice these and really just sometimes just staring at it and really thinking about it and just looking at it, looking at it, looking at it. Something will click into place. Okay? It's the kids that breeze past this and don't, they think that just like passing their eyes over it is going to like make it stay in their brain that get into trouble. Okay? So really, really understand what's going on here. That's it. Good luck. Email me any questions you have.